let's define a mole. A mole is the number of atoms that you have in 12 grams of carbon-12, which is the most abundant isotope of carbon. So imagine that you have 12 grams of carbon and you're trying to find the number of atoms here. So we write number of carbon atoms, and we find it by dividing 12 grams of carbon by the mass of a single carbon atom, which in this case is 1.99265 times 10 to the negative 23rd grams per atom of carbon. So we get 6.0221 times 10 to the 23rd carbon atoms. So this number is also defined as Avogadro's number, or N sub A, and this is also the definition of a mole. 1 mole is 6.0221 times 10 to the 23rd of anything, but as a general term we put particles. So in chemistry we generally use atoms for particles or molecules, but this could be any object that you can imagine. You can have 1 mole of grains of rice, where you will have 6.0221 times 10 to the 23rd grains of rice. You can have 1 mole of calculators, and you have 6.0221 times 10 to the 23rd calculators. So just remember that this number is written in scientific notation, but in fact it is a huge number, which is the following. So you have in 1 mole these many objects. Okay, so we also need to define a conversion factor that helps us to get from 1 mole to particles, and from particles to moles. So for every 1 mole we have 6.0221 times 10 to the 23rd particles. Or for 6.0221 times 10 to the 23rd particles, we have 1 mole. And this is the conversion factor that we will use in the following examples. So as the first case, let's go over how to convert from moles to atoms. So as an example here, we have how many atoms of sulfur are in 3.5 moles of sulfur. So in this case, we're going from moles to atoms. So we start with 3.5 moles of sulfur. And then to find the number of atoms of sulfur, we multiply by the conversion factor that has moles in the opposite direction as here. So in this case, it would be this one. So we have for every 1 mole of sulfur, we have this many atoms of sulfur. So carrying out the multiplication, 3.5 times this big number divided by 1, we cancel out the units of moles of sulfur, and we're left with atoms of sulfur. So by carrying out this operation, we get 2.1077 times 10 to the 24th atoms of sulfur. But we're starting with a number with two significant figures, so our final answer must have two significant figures. So because we have a 0 here, this number is rounded to 1, so we get 2.1 times 10 to the 24 atoms of sulfur. The next case is to convert from atoms to moles. As an example, we have the following question. How many moles of sulfur are in 5.8 times 10 to the 25th atoms of sulfur? So in this case, we're going from atoms to moles. We start with 5.8 times 10 to the 25th atoms of sulfur. And we have to multiply by the conversion factor that has atoms in the denominator so that it can cancel out with these atoms units. So we have for every 1 mole of sulfur 6.0221 times 10 to the 23rd atoms of sulfur. So the units of atoms of sulfur cancel out and we're left with moles of sulfur on the top. Carrying out this multiplication of atoms of sulfur times 1 and divided by Avogadro's number, we get, without simplifying, 96.3135 moles of sulfur. And because we start with two significant figures in the number of atoms, the last number must have two significant figures as well. So because we have a 3, this rounds down to 96. So we end up with 96 moles of sulfur. Next, let's talk about molar mass. Molar mass is the mass of a given substance divided by the amount of that substance. It is given in units of grams per mole, or AMU, which is atomic mass unit. The atomic weight is the numerical value of molar mass of an element. For example, for aluminum, its atomic weight is 26.982, and this is in units of grams of aluminum per mole of aluminum. So we can use this number for the case of aluminum to go from grams to moles or from moles to grams. As an example, let's look at this question. What is the mass in grams of 3.50 moles of aluminum? So we're going from moles to mass in units of grams. So we start with 3.50 moles of aluminum and we multiply times this conversion factor. In this case, 26.982 grams of aluminum for every 1 mole of aluminum. So the units of moles of aluminum cancel. Multiplying 3.50 times 26.982, without simplifying, we get 94.437 grams of aluminum. We see that we are starting with three significant figures for the moles of aluminum, so the final answer must have three significant figures. So the fourth digit is 3, which rounds down to 4 for the third digit. So we get 94.4 grams of aluminum for our final answer. We can also define the molar mass for a compound. The name of this is its molecular weight, which is found by adding the molar masses of the elements that make up that molecule. For example, what is the molecular weight of glucose with this molecular formula? So in this case, we're trying to find the molecular weight of glucose. So 1 mole of glucose with this formula has 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen, just from looking at the compound formula. Okay, so we need to find the masses of each one of these number of moles. So to do that, we need to multiply times its atomic weight. So for the case of carbon, the atomic weight is 12.011 grams of carbon per mole of carbon. So multiplying this gives 72.066 grams of carbon. For hydrogen, the atomic weight is 1.008 grams of hydrogen per mole of hydrogen. So we get 12.096 grams of hydrogen. For the case of oxygen, it is 15.999 grams of oxygen for every 1 mole of oxygen. Canceling the units of oxygen, we get 95.994 grams of oxygen. And we add this up and we get 180.156 grams per mole of glucose. So this final mass is for the total 1 mole of glucose, or this final mass is for 6 moles of carbon, for 12 moles of hydrogen, for 6 moles of oxygen. Okay, so the molar mass of glucose is 180.156 grams per mole of glucose. And 1 mole of glucose weighs 100.156 grams. Finally, we can define the molecular weight of an ionic compound. In this case, it is the sum of molar masses of the elements that make up the formula unit. The formula unit is just the formula of the ionic compound. For example, let's look at the following question. How many moles are there in 38 grams of potassium chloride, KCl? So in this case, we're trying to go from mass in grams to moles. First, we have to define the molecular weight of potassium chloride. So 1 mole of potassium chloride has 1 mole of potassium and 1 mole of chlorine. We multiply by the respective atomic weights, which for potassium is 39.098 gram of potassium per 1 mole of potassium. We cancel the potassium, mole of potassiums, and then we get 39.098 grams of potassium. And for the case of chlorine, the atomic weight is 35.453 grams of chlorine for every 1 mole of chlorine. The units of mole of chlorine cancel and we get 35.453 grams of chlorine. So we add these two numbers up and we get 74.551 grams for every mole of potassium chloride. Okay, so now we can use this molecular weight of potassium chloride as a conversion factor to go from mass to moles. So we have 38 grams of potassium chloride, and we multiply times this conversion factor in a way that grams is in the opposite way as this one, so in the denominator. So 74.551 grams of KCl for every 1 mole of KCl. So we get 0.5097 moles of KCl, and because we start with two significant figures, we have to approximate these to two significant figures. So we get 5, and then the next one is 1 because 9 approximates the third number into 1. So it's 0.51 moles of potassium chloride. That's our final answer. So what is the molar mass of potassium chloride? It is 74.551 grams per mole of potassium chloride, and 1 mole of potassium chloride weighs 74.551 grams.